This video will cover difficult questions part 1 regarding the topic of integration by partial fractions. The problems to be integrated this time do not seem to be related to partial fractions. However, if we change the shape of the rational function using substitution, we found that it can be expressed as partial fractions. Question 1. Use U substitution. Let U equal cosine of x. Derive on each side. du equals minus sine x dx. Then minus du equals sine x dx. Equals the integral of sine x dx is minus du over cosine x is u plus u squared. We can rewrite as the integral of minus 1 over, we can factor u times 1 plus u du. From now on, it's simple. The method of partial fractions gives minus 1 over u times 1 plus u equals a over u plus b over u plus 1. Then multiplying by the least common denominator, u times u plus 1, we have minus 1 equals a times u is cancelled, u plus 1 plus b times u plus 1 is cancelled, u. To solve for a, if u equals 0, then minus 1 equals a times 0 plus 1 is 1. Then b times 0 is 0. A equals minus 1. To solve for b, if u equals minus 1, then minus 1 equals minus 1 plus 1 is 0, plus b times minus 1. Then b equals 1. It follows that the integral of a over u is minus 1 over u plus b over u plus 1, b is 1, then 1 over u plus 1 du, then minus ln absolute value of u plus ln absolute value of u plus 1 plus c. Use the logarithmic property. We can rewrite as ln u plus 1 over u plus c. Then u was cosine of x. Final answer is cosine of x plus 1 over cosine of x plus c. Question 2. Use u substitution. Let u equal sine x. Then derive on each side. du equals cosine x dx. Equals the integral of 5 cosine x dx is du, sine x is u, then u squared plus 3u minus 4. The integral of 5 over, we can factor u plus 4 times u minus 1 du. The method of partial fractions gives 5 over u plus 4 times u minus 1 equals a over u plus 4 plus b over u minus 1. Then multiplying by the least common denominator, which is u plus 4 times u minus 1, we get the base equation 5 equals a times u plus 4 is cancelled, then u minus 1 plus the last one, p times u minus 1 is cancelled, u plus 4. To solve for a, if u equals minus 4, 5 equals 8 times minus 4 minus 1, which is minus 5, plus b times minus 4 plus 4 is 0. Then a equals minus 1. To solve for b, if u equals 1, then 5 equals 1 minus 1 is 0, plus b times 1 plus 4 is 5, then b equals 1. It follows that the integral of this one, a over u plus 4, a equals minus 1 over u plus 4 plus b over u minus 1, b equals 1, 1 over u minus 1 du, then minus ln absolute value of u plus 4 plus ln absolute value of u minus 1 plus c. Use the logarithmic property, we can rewrite as ln absolute value of u minus 1 over u plus 4 plus c. Then the final answer is ln u was sine of x, then sine of x minus 1 over sine of x plus 4 plus c. This is the last one. Use u substitution. Let u equal tangent x, then derive on each side. Du equals secant squared x dx. The integral of the numerator is du over tangent x is u, then u squared plus 5u plus 6 equals the integral of, we can factor the denominator 1 over u plus 2 times u plus 3 du. You should include one partial fraction for each factor and write 1 over u plus 2 times u plus 3 equals a over u plus 2 plus b over u plus 3. Then multiplying by the least common denominator, which is u plus 2 times u plus 3, we get the base equation 1 equals a times u plus 2 is cancelled, u plus 3 plus b times u plus 3 is cancelled, u plus 2. To solve for a, if u equals minus 2, then 1 equals a times minus 2 plus 3, which is 1, minus 2 plus 2 is 0, then a equals 1. To solve for b, if u equals minus 3, then 1 equals minus 3 plus 3 is 0, plus b times minus 3 plus 2, which is minus 1, then b equals minus 1. Back to the original, the integral of a over u plus 2, a is 1, 1 over u plus 2, plus b over u plus 3, then b is minus 1, then minus 1 over u plus 3 du equals ln absolute value of u plus 2 minus ln absolute value of u plus 3 plus c. Then use the logarithmic property, ln u plus 2 over u plus 3 plus c. Then the final answer is ln u was tangent x, then tangent x plus 2 over tangent x plus 3 plus c. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.